A monomial is an algebraic expression with one term. Here's what a term looks like. A term is a product consisting of numerical and variable factors. The numerical factor, or the number that's being multiplied, is called the coefficient. And then you'll see variables, maybe one, maybe more than one, and those variables are being multiplied and raised to powers. Those powers are called exponents. So this is a monomial. It just happens to have two variables. For the most part, we'll be studying monomials in one variable. A monomial in one variable is a term of the form ax to the n, where a is a constant and n is a whole number. So a is that numerical factor called the coefficient, x is the variable, and n is the exponent. So here's an example of a monomial in one variable. So we have the coefficient, or the numerical factor, 12. We have the variable x, and we have the exponent, or the power of 3. So this is a monomial in one variable. A polynomial is a monomial or two or more algebraic terms combined by addition or subtraction. So now we're going to start adding and subtracting these monomials. And when we add and subtract multiple monomials, we get what's called a polynomial. But it turns out a monomial itself is also a polynomial, so it fits under that umbrella. Here's an example of a polynomial. This is more than just one term. Here I have 12x to the third, which is one term. Then I have negative 7x squared, which is a second term. I have 3x to the first, which is a third term. And I have negative 5, which can be looked at as negative 5 times x to the power of 0, making that the fourth term. So this polynomial consists of 4 terms. All right, 4-term polynomial. When a polynomial consists of 3 terms, we call that kind of polynomial a trinomial. So a polynomial with exactly 3 terms is a trinomial, and a polynomial with exactly 2 terms is called a binomial. So here's an example of a binomial. That one has 1, 2 terms. And here's an example of a trinomial with 1, 2, 3 terms. All right, now let's talk about the degree of a term. The degree of a term is the sum of all the exponents on its variables. So let's take a look at this term here. This term has 2 variables, x and y. And those variables have exponents 4 and 7 respectively. So the degree of this single term is the sum of the exponents on its variables, which is the sum of 4 and 7, which is 11. So this monomial has degree 11. When you look at a constant, it doesn't have a variable. So the degree of a constant is 0. For instance, this term has degree 2 because the variable is raised to a power of 2. This term has degree 1 because the variable is raised to a power of 1, even though it's not written. And this term has degree 0 because there is no variable. So the degree kind of tells you how many variables are being multiplied in that term. So here you have 2 x's being multiplied, here there's only 1 x, and here there are no x's. So that is the degree of each individual term. The degree of the entire polynomial, on the other hand, is the highest degree of all its terms. So I had here a degree 2 term, a degree 1 term, and a degree 0 term. And the highest of those 3 degrees is degree 2, making this entire polynomial a second degree polynomial. So the degree of a polynomial is just the highest degree of any term in the polynomial. So now that we have all this vocabulary, we're going to go ahead and start adding and subtracting polynomials. So when 2 terms have the same variables raised to the same powers, the distributive property can be used to combine these like terms. When we say like, we mean they have the same variable raised. When we say like, we mean they have the same variables raised to the same powers. And here's the distributive property, in case you've forgotten. The distributive property, it usually starts from the right side, is A multiplied by the quantity B plus C. Then it says that that's equal to A multiplied by B plus A multiplied by C. But we're going in the other direction here. We're going to have two terms that have a common factor of A, and we're going to pull that common factor outside of a parenthesis and then take that common factor out of each term. So let's go ahead and do that with a binomial. So here we have a binomial. You'll notice that they share a factor of x squared. So they both have a factor of x squared. They also both share a factor of 3. But right now I'm focusing on combining like terms. So I'm looking at the factor of x squared that they share. Based on the distributive property backwards, we can take that x squared and put it outside of a parenthesis, and then take that x squared out of each term, each original term. So that's taking the x squared out, putting it outside of a parenthesis, and then when I take the x squared out of each term, I'm just left with 3 plus 9. But 3 plus 9 is actually an operation I can do. 3 plus 9 is just 12. And there we've combined the two terms that had the same variable raised to the same power into a single term, combining of like terms by addition. So this is what we're going to do when we are adding and subtracting polynomials. We're basically going to take any terms that are alike and combine them together by adding or subtracting their coefficients as indicated. So here we have an example. We're adding 3x squared minus 7x plus 5 to negative 9x squared plus 4. So first of all, because it's addition, I don't really need the parentheses, so I'm just going to drop the parentheses. The plus or minus 9x squared is just going to be a subtraction of 9x squared. So these are the same two polynomials, the trinomial and the binomial. Once again, plus or negative is just subtraction. And now I'm going to rearrange them. The terms that are alike, I'm going to put them together. So the 3x squared and the negative 9x squared, the 5 and the 4, those are like terms, those pairs. And the negative 7x doesn't have a like term. So I'm going to put the 3x squared with the 9x because those are like terms. I'm going to put the 5 with the 4 because those are like terms. And negative 7x doesn't have any like terms. So these two can be combined. They both have the variable x squared. So that means that all I have to do is subtract these coefficients. 3 minus 9 is negative 6. And likewise, 5 plus 4 we know is 9. So we get negative 6x squared from combining these two like terms. The negative 7x didn't have any like terms, so it stays the same. And the 5 plus 4 is equal to 9. So that's how you add two polynomials together. Subtraction, a little bit more involved. So let's take a look at a subtraction problem. Here we have 5x squared minus 3x plus 4 minus negative 9x squared plus 7x plus 12. And the difference here is because of this negative in front of this second parenthesis, that is like multiplication by negative 1, which means we have to distribute that multiplication to all three terms, which is going to change the signs of all the terms in the second polynomial, the one that you are subtracting. So that means we'll have negative 1 times negative 9x squared, which is positive 9x squared, negative 1 times positive 7x, which is negative 7x, and negative 1 times 12, which is negative 12. So you'll notice all the terms in the second polynomial changed signs from what they originally were to their opposites. The first polynomial stays the same because there was no negative to distribute there. Now I'm just going to combine like terms. So I'm going to put the like terms together, the 5x squared and the 9x, the 3x, the negative 3x and the negative 7x, the 4 and the negative 12. So I group them all together. Then I'm just going to combine them by adding or subtracting their coefficients depending on what the signs of the coefficients are. For instance, the 5x squared and the 9x squared, we add those together and we get 14x squared. The negative 3x and the negative 7x, we combine those, we get negative 10x, and the 4 and the negative 12, the constants, we can combine to get negative 8. So if I subtract these two trinomials, this is the resulting trinomial. So that's how we add and subtract polynomials. Right. The last thing I want to talk about is evaluating a polynomial for a given value. So the notation f of x represents a function with the name f and declares the independent variable of the function to be x. So as you can see here, here's an f of x. F is the name of the function, and if you look on the right side, the only variable that you can plug stuff into is x. So the declaration here is that your independent variable is x. This notation means they want us to replace the independent variable x with the number -3. So the f of -3 is what you get when you rewrite the original expression with -3's plugged in for x's. And then all you have to do is follow the order of operation. So PEMDAS, the first thing we would do is what's inside of parentheses. But there are no operations inside of the parentheses to do. So the next thing we do is exponents. -3 squared. Well, -3 times -3 is +9, but that negative that was in front of the parentheses still has to come down. And that was the exponent steps. So next we do multiplication and division, whichever comes first, from left to right. So let me see here. There's only this multiplication to do. 5 times -3 is -15. And then lastly, we have addition and subtraction from left to right. So that's going to be -9 minus 15, which is -24. And then -24 plus 2 gives us -22. So that is how we evaluate a polynomial function for a given value. And this is the notation that would indicate that we need to do that.